All right, this is section 2.5, day 2, and we're just going to take our idea of imaginary zeros and functions and see if we can continue to kind of find more and more difficult zeros. So first one says find all the zeros of. So when they say all of them, we're talking about real and imaginary. I have a fourth power, which means there are 4 zeros to find. At most, out of these 4 zeros, I could have 2 of them be imaginary and another 2 be imaginary. Or I could have 2 real and 2 imaginary. But I remember these guys all come in pairs. So if I have 4i, I also have negative 4i right as a start. So it's kind of like you get a buy one, get one. So I'm going to use that 0 and I'm going to create a factor. So x minus 4i and x plus 4i. I cannot long divide an I out of this. I can't even synthetically divide an I out of this. But I do know this sweet little trick that when I FOIL this together and get x squared minus 4ix plus 4ix minus 16i squared, cancel that, turn it positive, get rid of those, I actually don't have any i's, so they're kind of hidden in this. This I can long divide. So I'm going to take x squared plus 16 and I'm going to long divide that out of my function. Remember, we can use long division or synthetic in order to help us break the function apart so that we can continue factoring or quadratic formula. So I'm going to use long division to take this out of here so that I can see what I've got left, and hopefully we'll be able to factor that. So in order to turn an x squared into x to the 4th, I'm going to need an x squared. So that's going up top. Then I'm going to multiply by the front, so x to the 4th. And 16x squared. Draw a line, switch your signs so that 2x cubed is coming down. And then I've got 8x squared minus 16x squared, so negative 8 squared. Now how does x squared become 2x cubed? I'll need a 2x to do that. And then 2x times x squared is 2x cubed. And then 2x times 16 is 32x. I'm going to move that over here so it's like terms. Draw my line, switch the signs so that negative 8x squared will drop. 32x minus 32x is nothing. So now I'm making that x squared become that 8. And all I'm going to need is a negative 8, so I'm going to throw that up there. I've got negative 8 times x squared. Excuse me. Negative 8x squared, and then negative 8 times 16 is negative 128. Draw a line, switch the signs, that goes away, and this goes to 0, which should happen because my x squared plus 16, those are zeros of my function. So when I divide them, I should get 0 for a remainder. So now we're looking at what got left over. I took those out of our function. This is left. So I'm just going to take that, and you've got some options. You can factor. You can quadratic formula. You could graph it and look for the x-intercepts. So you have a couple of different options. I'm just going to factor because I've been factoring for years. So things that multiply to 8 are 8 and 1 and 4 and 2. That's the only option that can get me to a 2. And that's positive, so the 4 is positive, and that one's negative. So my 0 here is negative 4, and my 0 here is 2. So 2 and negative 4, I'm going to add them to the list, and now I have all of my zeros that happen in this function. 2 imaginary and 2 real. Next one, same kind of idea, except this time we're not starting with an imaginary 0, we're starting with a real 0. So I have a cubed, that means I have to find 3 of them. Excuse me. And I can synthetically divide a real 0, so I'm going to throw that in the corner. 1, negative 3, 16, and 20. Drop the 1 down, times by negative 1, times by negative 1, times by negative 1. So good thing I got 0 for a remainder. That should happen when I have a 0. So negative 1 was my first 0. We did synthetic. We found out that I have x squared, negative 4x plus 20 left. I have the same 3 options. So I'm going to attempt to factor this. If that doesn't work, we can use the quadratic formula or the program. or we could graph it to find our x-intercepts. Graphing is super tricky if you're looking for the imaginary ones. Your calculator can't do that. So bam, it can't do imaginary, it can only do real. So I'm going to attempt to factor this one. I'd still have an x and an x. 20 could be 1 and 20, could be 2 and 10, could be 4 and 5. None of those is going to get me to a 4, so factoring is not going to work. So I'm going to turn to the quadratic formula. X equals negative b, so a negative 4, b squared minus 4ac all over 2a. Well, simplifying, this is just 4 plus. Under here we've got 16 minus 80, and then over 2. 4 plus or minus 16 minus 80, you are going to end up with a negative. This is why your calculator can't do it for you. It's going to be negative 64 all over 2. But we know how to deal with a negative. I'm going to peel that negative off of it and leave the square root. And now I know the square root of 64. So 4 plus or minus, that becomes an 8i all over 2. And make sure that all over 2 stays, because we're going to divide each of these by 2. So dividing this by 2 leaves me a 2, and dividing this by 2 leaves me a 4. So final answer in all of that, I get 2 plus or minus 4i. These are my other two zeros. Remember, imaginary always come in pairs. I get the positive version and the negative version. So 2 plus 4i and 2 minus 4i. Those are my 3 zeros. The imaginaries came in pairs, and then I had one real zero. So using our zeros and our idea of imaginary today to continue finding them. If you are dealt an I, you always have to have its partner. Foil that together so you can get rid of the i's so you can't see them, and then you can long divide. Otherwise, a little synthetic division with a quadratic formula.